So back with our second example in this little set of using trig identities. The equation we've got here, we are actually going to solve between 0 and 360. Sorry, I should have put that as well. We're going to solve, but we've got to think before we start this time. We've got a cos 2x and a sin x. Now, cos 2x is a little different to what we did a minute ago, because when you've got a cos 2x, there are a couple of options. You can either replace it with, and this is from your formula sheet again, or your notes from back in December time. You can either use a cos squared minus sine squared, or you can use 2 cos squared x minus 1, or you can use 1 minus 2 sine squared x. So you've got these three possible options this time, which is a little bit different to our last equation. We didn't have options. There was only one identity for sine 2x. Now, if I'm looking at this equation, in a moment, we want to deal with sine x's. Because the other thing, we've got our cos 2x term. The other thing in our equation is a sine x term. As soon as I see that, I am thinking I want to replace my cos 2x with the version of this which involves sine. So that's how I'm making my decision what to replace my cos 2x with, by looking at the other thing that's in my equation. If it said cos x here, I would use this one. And in the case of solving an equation, this one is very rarely useful. So it's either going to be this or this, depending on if the other thing in your equation is a cos or a sine. So let's replace it. We've got 1 minus 2 sine squared x plus 3 sine x equals minus 4. Now we want to rearrange and see what we can do with this. We've got a squared term, we've got a normal term, we've got some numbers, so the realistic thing to aim for is to rearrange to some kind of quadratic. It'd be easier in life if we had a positive number of sine squared, so I'm going to move that over. So we're going to get 2 sine squared x on this side. I'm just going to write some intermediate steps. I'm just moving that over. I've not written this line in a particularly obvious way. So all I've done, I've got the 1 plus the 3 sine x still on this side. I've added that to that side. Now I'm going to take the 3 sine x off. So I end up with 2 sine squared x minus 3 sine x. And it's a quadratic I'm aiming at, so I want it equal to 0, so I'm also going to take the 1 off both sides. So there is a quadratic. We've got a squared term, we've got a not squared term, we've got just a number term equal to 0. Well, just like we were doing back in the previous task 1, we want to turn that into a quadratic and solve it. So let's look at that as a quadratic first. So it's 2y squared minus 3y minus 5 equals 0. Factorizing that, we want two things that multiply to give minus 10, add to give minus 3. Well, the option for that are 5 and 2, and the 5 better be negative. So we've got 2y squared minus 5y plus 2y minus 5 equals 0. And then working with that, we can factorize y out of the first two terms, and we get 2y minus 5 left. There's nothing to factorize out, so I'll put a 1 outside. And so our factorization is y plus 1, 2y minus 5. Okay, so that is our kind of quadratic solving, but now we relate this back to what we had up here. So instead of our y's, we're using sine x's. So we have sine of x plus 1. And our other bracket is 2 sine x minus 5. And those equal 0. Quite a bit of work in this to rearrange, but we are now down to this bit where we've got two trig equations. We've either got sine of x plus 1 equals 0, or we have 2 sine x minus 5 equals 0. Now, actually, cunningly, I've picked quite a nice example here, because if we rearrange this side, I'll come back to this one in a second. If we rearrange this side, we get 2 sine x equals 5. So sine x equals 5 over 2. But hang on, thinking of our sine graph, it only goes up to 1, and it only goes down to -1. 5 over 2, that's 2.5. Never gets there. So sine x, you put that in your calculator, it'll give you an error. If you do sine to the -1 of 5 over 2, that'll be an error because sine graph never gets as high as that. So this side has no solutions. That will not always be the case, but I have picked it here just to keep our video brief, because the key focus of this video is being able to deal with a cos 2x and transform it into a trig equation that we can then solve. This side, we get sine x equals -1. Using our trig, our sine graph, sorry. When are we at -1? Well, it's here when we are at 270 degrees. So the only solution between 0 and 360 for this equation is x being 270 degrees. Now, it's rare that a trig equation would only have one solution, but sometimes they will, and it's just about working through the numbers you're given and seeing how it works out. So, have a go for yourself. The one I want you to have a go at is this one here. Very similar, we've got cos 2x. There is a bit more detail to deal with when you come to the solving trig equations for this bit. So pause the video, have a go, and I will run through the solution in just a moment. Right, so let's have a look at what we've got. So first thing, I've spotted the cos in this equation, and so I've replaced my cos 2x with 2 cos squared x minus 1. I've replaced it with the cos version of that identity because I've got a cos for it later on in my equation. So that's step number one. That's thing number one that we need to kind of keep in mind, is which one to replace it with. Once you've replaced it, we can expand. So we get 6 cos squared x minus 3, because just multiplying everything by 3 there. I've simplified, so I've turned it into a quadratic. The quadratic I've written as y's, and then I've gone on to try and solve that quadratic. So I've factorized, and when I factorize, I got 3y minus 2, 2y plus 1, and then I've replaced my y with my cos. So this is the key transformation, is being able to take our original equation and turn it into this. Once I'm there, I've got 2 equations to solve. Cover up that one. So the first equation I'm solving is when the 3 cos x minus 2 equals 0. And that gives me 2 angles eventually, which are 48.19 and 311.81. So there's my full solution to that. Very standard process, hopefully by now, this trig equation bit. On the other side, solving 2 cos x plus 1 equals 0, we get minus a half being cos x. And we can solve that. That's actually an exact value if you spot it. Gives us 60 degrees for our relative acute angle, or 120 when you do the with the negative in there. And the other angle you get out of that is 240. There are 4 answers displayed down the bottom there. Now, I am aware that there's a huge amount of work in that, but these would be richly rewarded in terms of marks in an exam paper. Here you've used a trig identity. As I said at the beginning, that would be kind of our part A of a question, would be taking a trig identity and being asked to turn that equation into this equation. That might be a part A in the question. And then part B would be to solve this equation, where we've got 2 trig equations to solve, and we've got some exact values to watch out for. So lots and lots of different things, lots of different skills that we've been doing recently involved in this. But hopefully you're seeing those skills building together to give us a solution. There is one final kind of equation that I am going to show you, and that is in video 3. So keep going through to video 3 and watch that last type of equation, and then you can have a go at some of the examples for yourself.